Okay, so first question. We want to construct a box with a square base and we only have 10 feet squared amount of material for the construction of the box. Assuming that all the material is used in the construction process, determine the maximum volume that the box can have. So first step, we figure out what's going to be maximized and minimized. So it says maximum volume, so we put maximum volume. We also draw a sketch to get a visual idea of what we're looking at. So your length is equal to your width because it's a square base. So square means length is equal to the width. Here, second part, we figure out what equation we use. So we're looking for volume right here. So we write our volume equation. So length times width times height, and then the length is equal to the width. So we can go ahead and plug in our length so we can find our volume. The third equation is we're trying to get V to a single variable. So in order to do that, you have to use our surface area, which is up here, to find our relation between H and W and L. So in order to find that, we go ahead and put our surface area out. So 2LH plus 2LW plus 2WH is equal to 10. So now we plug in our relationship here because we're trying to find H. So we plug in our L is equal to W. We have 10 is equal to 2WL, or H, plus 2W squared plus 2WH condenses down to 2 minus W squared equals 4WH. H is equal to 10 minus W squared over 4W. So over here we can cancel that out and come over here and write 10 minus 2W squared over 4W. So now we can use our H here, plug it in up here for our equation to get it to a single variable. And our single variable is going to be our W, our width. So now we plug it in up here for our third step, and we have volume is equal to 1/2 5W minus W cubed. And the fourth step is we come to number 4, and that's take the derivative. So we start with our velocity, or not our volume, my bad, is equal to 1/2 5W minus 5 cubed, minus W cubed. So our volume is equal to 5/3 W minus 1/2 W cubed. I went ahead and distributed so it's easier to take the derivative. Now our V prime, which is our derivative, is going to equal 5/3 because our W goes away down here. So there's still a W there, but W comes down, or it doesn't come down like that. And our next one is take our 3 to the front, so 3/2 W minus 1 from the exponent equals 2. And then we have to set it equals 0 in order to find our width. So our 5W minus 3W, the 3/2 W squared, and then we solve for W by bringing this to the other side. Solve for W, so we have W is equal to the square root of 10 over 6, or 1.2910. Now our length is equal to our width, so our W here and our L are the same. So our L is going to be 1.910, or square root of 10 over 6. Our H we found up here, we can bring down here, and we solve it for our W, so we can find our H as well. So we plug in our number here into our equation. So H is equal to 10 minus 2W squared over 4W. Our H is equal to 10 minus 2 times 1.2910 squared over 4 times 1.2910. So our H is going to end up being the same. So in this case, it's a perfect cube. So everything's equal. And it just happens to be like that because of this certain equation. And so for this one, now we have to find our volume, because we're trying to find the maximum volume. So in order to use our maximum volume, since our H is equal to our L and everything, we just have volume is equal to W cubed. So volume is equal to 1.2910 cubed. So our volume is going to end up being 2.1517 feet cubed as our maximum volume possible for this cube.